Hello, everyone. We will start our third webinar. Welcome to Unit 3. This is our third webinar for Unit 3. Today, Eduardo will not be able to be with us, so I will conduct this webinar, and we will mainly review the 3 steps of our PubRisk tool. And then we will go in detail in step 2, which is the quantitative analysis using panel data, which is what is about our Unit 3. So, the overview of the PubRisk tool. I know that we went through this on the last webinar, but I think that still it is very important to keep it in mind and to take it again. So why we are doing this, why we're interested in poverty dynamics, what we want to do is to test those determinants of moving up and down of poverty. And we have done this, the UNDP team of New York, we did this for 18 countries of Latin American region. And we use panel data for 18 countries, and what you can see in this picture is the income pyramid of a Latin American population divided by income groups, and we find out that there is around 10 to 13% of vulnerable population, the one in yellow, that is at risk of falling back into poverty. And we found this using the same methodology that PubRisk. So we think that is a very important conclusion, and it is very worrying that there is around 10 to 13% of vulnerable population that have a great probability of falling back into poverty. And in the same study, we also found for these 18 countries which are those determinants for going out of poverty and to avoid sliding back into poverty. And we found out, using this panel data, that educational labor market characteristics are mainly related with those factors to exit poverty. But to avoid sliding back into poverty, social protection systems of care, access to assets, and labor market qualifications are very, very important. So we call this group of factors our basket to shape policy on these Latin American countries. And we decided, after doing this study, that we would like to know for each country which are those factors and which are the weights for using panel data of each country. And that is why we are doing this PubRisk course, because we would like to find out this determinant in each country of our region. So why we think that is important, knowing this factor associated with upward and downward mobility? It's important because it has a very important implication for public policy decision. Our final product will allow us to know which is the policy mix required to eradicate poverty in each country. And for that, we need to work in both upward and downward factors. We need to break through structural factors that hinder progress, and we need also to have a comprehensive approach that includes all multiple dimensions that are part of multidimensional progress of household. And we think that if we want to understand how to eradicate poverty in each country, it's very, very important to understand the dynamics of each household. That is why we're using household surveys of each country. So this is the final product. And these are the 3 steps of our PubRisk analysis tool. Just as a review, in Unit 2, we went through the construction of panel data. we have two big options: to have a national level panel data available, or to have to construct our own synthetic panel. In Unit 3, the current unit, we will go through the quantitative analysis using panel data. We will construct the transition matrix, and we will find out those determinants for exiting poverty and to avoid falling into poverty. And in our last unit, on Unit 4, we will take this quantitative analysis of Unit 3, and we will create a basket for policy decisions, linking those quantitative information to each country context. And we do this because we know that household surveys doesn't capture all the multiple dimensions of progress, so we have to analyze each country context to make the best policy recommendations. So, just as a review, our final product of step 1, it was a file in which we have all variables at the household level. We have one record for each household, and in which we have built the dependent and independent variables for the regressions. So everyone have learned in Unit 2 that we need to construct these the variables of class for both periods, and also we have to construct a set of characteristics for each household. And for example, here in this green square, you have a household that was vulnerable in 2001, and it was a middle class on 2006, and so on for each household of our database. This database that we have created on Unit 2 will allow us to do our econometric analysis to find out those determinants for both transitions. So this was the product of step 1, and now let's go through step 2, the quantitative analysis using this panel data. So what is the first thing that we're going to do with this panel data? The first thing is we want to know all the movements of households in our data. And for that, we will construct our transition matrix. The transition matrix allows us to see upward and downward movements of each household over the 2 periods that we have. We want to analyze the income per capita trajectory of each household. So we will have that in moment 1, we classified in the last unit each household in poor, vulnerable, or middle class. And in moment 2, we will have 3 options: that each household experience an upward movement, a downward movement, or no movement. So how we construct our transition matrix, it's very simple in Stata. We just use the command tabulate. The short name is tab. We write down our 2 variables, and we ask the version that we have the row percentage. That's why we put an R. And what we will get, just typing that in Stata, we will get this table, and this table, that it looks very simple, but it have a lot of rich information for our analysis, because you can see that here we have classified for both periods in 2001 and then in 2006 all households of our database. In this case, this database has 3,126 households. So just as an example, we can know from our transition matrix that 6.7% of vulnerable households in 2001 were poor in 2006. That is 90 households. We know from the first number of the table. So this is very important, because in the diagonal we will get all those households that didn't experience mobility over time, and also we will get the classification of each household, and in our database, with the variables that we have constructed, we have a very rich information, and we can create profiles for each group of the transition matrix. For example, for this group that we have in blue, I can get which is the average of head of household education. I can get which are the number of female head of household, the average of children per household, and so on. So that this information is not still we haven't do the quantitative analysis, but it still can be very useful. You can create a small report about all the characteristic of each group of the transition matrix. And also it's important because you will know which have been the most important trajectories of your panel data. For example, here you know that most of households didn't experience mobility. There is an important group that that stay in vulnerable situation, and also an important group that stay in middle class. So that is a very important information for your analysis. So once we have constructed our transition matrix, we will start the quantitative analysis. So this equation that you see here is our model, and we will run 2 regressions using this model. One regression for each transition. We will call regression 1 to the transition from poor to vulnerable or middle class, that is household that went out of poverty over time, and we will call regression 2 the transition from vulnerability to poor, that is those households that fall into poverty over time. So we have constructed in our last unit all these variables, this set of characteristics in year 1, which have information of demography, geography, head of household characteristics, labor market resources, social protection, ownership of assets, dwelling characteristics, risk management, and coping variables. These are all the type of characteristics that we create for household in the last unit, and also we create a set of time-varying characteristics. That is, using both periods, we, for example, calculate which is the number of households engaged in paid employment over time, how the household size change over time, and in some databases it's possible also to capture the occurrence of shocks over time. So this is our independent variables, and our dependent variable is going to be a binary variable that for regression 1 we will take the value of 1 when households were poor in moment 1 and they were not poor in moment 2, and the value 0 when households were poor and they stay in poverty over time. And using the same logic for regression 2, our binary variable, we will take the value 1 when households that were vulnerable in the first moment were poor in the second moment, and the value 0 when households were vulnerable in the first moment and were not poor in the second moment. So we will construct this variable, and we will run this model for both regressions. So the first step here is what we did in Stata. The first that we have to do is to create the dependent variable. So here is the command to create we call that variable salida. This is for the regression 1, and you don't have to, this is just an example, you don't have to use the same name or to do exactly the same in Stata, But this is how we create our binary variable to run the regression. And here we have the commands that we use to run our stepwise model. Why we use a stepwise model? Because in this case, as you can see, we have a lot of potential independent variables, but we don't know which of them we should use. So what we do with the stepwise is that we use all the variables, and the stepwise we will give us back all those explanatory variables that have a significance at the 95% level using a backward selection. So this procedure allows us to keep only those significant variables for the model. So here you can see how we run. This is the command stepwise. And then we store all the results in Excel. So this is our first step of the quantitative analysis. Once we run the stepwise model, we will keep those variables that we get that are significant, and we will run with those variables a simple Probit model. Why we do this? Because there are some errors made with the stepwise procedure, so we want to test consistency and to avoid overfitting of variables. So here you can see what we did in Stata. Again, it's not necessary to do this. We use a local to clean the list of variables that we get from the stepwise. You can do this manually. It's not necessary to do a local, and you can just directly look at the Excel file that you will get or to your Stata screen and to get those significant variables of the stepwise, and then to run a simple Probit with those significant variables. Not necessary to do all this procedure. But the important thing is to, after the stepwise, to run the Probit model only with those significant variables. And then we keep all the results of the Probit in the same Excel that we keep the stepwise results. So how this look in Excel? The Stata we put in Excel the results of both regressions. So here is the example for the first regression, for the regression of out of poverty, and here you can see that for the stepwise Probit we get these variables, and for the simple Probit we get this the second row of variables. So the one of the second regression are the one that we are going to use to estimate the marginal contributions in the next step. We will keep also only those significant variables at 95% confidence of the Probit model. So it's important to look at this Excel table to check what we get and to keep only those variables that are significant. So this is how the results look in Stata. And here is how we calculate the marginal contributions. What we have to do for calculate the marginal contribution is to the group of variables that we get from the Probit model to calculate the median value, and in the case of binary variables, and the mean value in the case of continuous variables. Why we are doing this? Because with the marginal contribution we want to get what is the marginal taint of a specific variable, but keeping all the other variables constant. And we want to keep all the variables constant in a representative home of our survey. So the way that we think that we can do that is finding those mean value of each variable that we are using. So that is why we use, in the case that we have binary variables that take the value 0 or 1, the mean doesn't give us too much information, so we use the median. And in the case of continuous variables, we use the mean. So here is how we did this in Stata. Again, it's not necessary to do the same commands. You can, if you want, you can manually calculate the median and the mean of each variable, but it can be useful, this command, to calculate it on the Stata. So once we have our mean and our median for all the variables, we'll calculate the marginal contribution. With the command mtaint, we estimate for each variable the marginal contribution to the probability of transition. So, as you can see here, this is the command in red, and you can see in this square how we have fixed on the mean and median value each of the variables that were significant on our profit model. So what we're exactly doing when we calculate the marginal taint, we are shifting the value of a given characteristic from 0 to 1 in the case of binary variables, or in an additional unit in the case of continuous variables, one at a time, while keeping constant the other significant characteristic in the value of a representative household in its transition. I know that this sounds a lot, and it's a lot of information, but this is the formal explanation of what we do when we run the marginal contribution. And what we want to do is to know the significance of adding an additional unit of each variable while keeping the other constant in a representative household. And we get, as I said, the representative household, fixing the values in those median and average values. For example, in this database, to have one children, those average household have one children per household. They don't have sanitary system. They have one household working, and so on. So we want to get that representative home in order to estimate the effect of changing one characteristic at a time. So again, once we run the marginal taint, we will put in Excel all the results, and what we will get in Excel is this small and simple table. But this small and simple table is all our results that we will use to construct our policy recommendation in next step. So what we have here, this is the case for regression 1. It's important to notice that in all these examples, we are doing the analysis for regression 1, and we have to do the same for this regression 2, which is the transition of going into poverty. So what we got is, here you have for each variables, you have two alternatives. You have the taint from 0 to 1, and you have the taint plus 1. So what value you will use, it depends on the type of variable. For example, children 2001, it's a continuous variable that have the value that it takes the value that of the number of children that each household have. So in this case, because it's a continuous variable, we will use the plus 1. But for example, the variable sanitary system is a binary variable that only have value 0 to 1. So in that case, we will use only this value because it doesn't make sense to use the +1 because it's a binary variable and not a continuous variable. So we have to choose for each variable which value we use, and then we also look to the p-value to know the statistical significance of each marginal contribution. So, for example, for the case of an additional children, we use +1. So how we read these results, we said that an additional children per household reduce the probability of going out of poverty in 5 percentage points. That means that for this database, those households that have more children will have a less probability of going out of poverty. And that is a very important message for constructing system of care and a social protection system that that doesn't make that children are that reduce for household the burden of having children. So it's important to make the right interpretation for each of these variables. And here you can see that in here we have created a table that summarizes the findings of this Excel table. So here you can see that this is for regression 1. You have the same value, 0.051 that we have here for children. So here we have those variables that are significant for the transition from poverty to vulnerability or middle class. And here, in the right side, we have the same for the transition from vulnerability to poverty. It's important to notice that to construct this table, we have to run the stepwise model, the profit, and the marginal contribution for the second regression. So we have to repeat all this procedure for the other transition. So here you can see which are the main results of our study in this case. And for example, also you know that for a head of household with pensions, there is an increasing probability of going out of poverty by 11.8 percentage points. So with this econometric analysis, with these two tables, we will be able to construct policy recommendations, and we will be able to analyze each of these determinants and know if there are differences between going out of poverty and between those determinants for avoiding sliding back into poverty. It's also important to notice that we include the average probability of the transition, that this probability is also possible to get from the marginal contributions. So this is our final product of the quantitative analysis. This is the final product of Unit 3. And to summarize, which is the main challenge of our PopRisk tool is to able to have data to study household mobility. And Unit 2, we construct a database that allows us to do a mobility study. So in this step, we will able to perform econometric analysis to be able to analyze household mobility. It's important to understand the context of each country for the variable construction and data interpretation. In this exercise, we are using all the time a Chilean database, but in the case that in the future you in other countries you did this exercise, it's important to understand country context and also to construct the appropriate income groups, because In this case, we are using as a threshold $4 per capita as a poverty group, but maybe for other countries that is a very high threshold, or maybe in another countries is too low. So the income group is important to construct it according its country context in order to make the best studies of household mobility. And to summarize our second unit, step 2, it have like 4 main steps. The first one, as we saw, is the transition matrix, and then we have 3 small steps for the quantitative analysis. The first one is the stepwise probit regression for each transition. Then we run the probit regression with the significant variables of the stepwise model for also each transition. And finally, we calculate the marginal contribution of the significant variables that we get from the probit regression. And to finalize, our next and final step that we will go through in the next unit, unit 4, is the construction of the basket of resilience to vulnerability and the basket for going out of poverty based on the analysis of this unit. And this basket identifies those public policy intervention necessary for progress. So thank you very much. Please let me know if you have any questions. And I want to say that I have been looking for your Stata homeworks, and I have to congratulate you, because for those that take the Stata track, you have done a great job. And I know that this can be a very technical course, and that's why we have 2 tracks. So I know that some going through some Stata code can be a little difficult, but still all of you are doing a great job. And please, if you have any question regarding Stata or our methodology, use the forum, or you can email me or Eduardo if you have any questions. So I will see if here in the chat we have any question. And so here is a question and suggestion of Patrick. Yeah, we know Patrick said that we should have a handout or coding for household data for Stata or other statistical software. Yeah, we know that for people that are doing this course, it's necessary to have Stata coding knowledge. That is why we ask for those that want to join the Stata track to have some Stata knowledge. But still, it's true that we should teach a little bit about Stata coding, and we include, I think that is, I'm not sure if it's like a complementary reading of unit 1 or 2. We have a tutorial of Stata. I'm not sure if it includes all the commands that we are using in our course, but it includes a lot of coding. So I can send it to you so you can look at it. It was prepared by some colleagues of UNDP. And also I can give you some links of some tutorials where you can find more about Stata coding. But I know that it's very important to know that for the course, but we don't have enough time to do 1 unit only of Stata coding. So that's why we include as a complementary reading a handbook. And also there is a question, and is a binary variable the same as a discrete variable, non-continuous? A binary variable is those variables that take the value 1 or 0, and we have construct this. Wait me a second. Yes, a binary variable is a variable that takes the value 0 or 1, and yes, it's the same that a discrete variable. You can use also that name. So there is a question of Wilson that Wilson said, this is useful for one SDG focused on poverty reduction. Is your group looking at the same approach for other SDG? I know poverty is more straightforward because you can calculate poverty line. It is possible with other areas like environment or governance or education. Oh, thank you, Wilson, for this question. It's a very good question. Yes, one of the limitations of our POVRIS tool is that the data allow us only to analyze poverty transitions. So that is why this is a tool dedicated for SDG number 1 for the eradication of poverty. But we are working on other tools for to achieve other SDG goals. As for example, we have a tool that we call combos. It's like cluster in English, and we will also have a virtual course of this in the next months. So if you're interested, you are welcome to join this course. And in this course, we will teach about other techniques to achieve the other SDG that are not possible to analyze through this data, because as you can see, household data have a lot of limitations, and one of them is that you don't have information, for example, about gender inequality, about environmental issues, and about a lot of topics that our SDG agenda covers. So that is why this specific tool allows us only to analyze income poverty. But we will have another course to try to achieve other type of objectives related with the other SDG. There is also a question of Alistair. Can we use a logit model? I'm not sure, Alistair. I think that the difference between the logit and a Provit model is very small. So I think that you can use it, but I remember that the first time that we try this, we test with the logit model, and it seems that the data works better with the Provit. So I think that it depends of the data. At the moment, we have been using only Provit, but I can check how it works with this specific data, and if you want, I can send you a message through our forum or an email to let you know how it looks, if you can use the logit model. And so I don't know if there's more question. Okay, so thank you very much for participating in this webinar. Please, if you have any type of question, let us know. I know that this webinar, it was more focused on the econometric track, or for those students that are doing the STATA homework. So I'm sorry for those that are in the other track, but still I think that it's very useful for all students, of both tracks, to go through this, even if you're not willing or thinking on working on STATA. It's very important to know how we get our marginal contribution results. And also, I think that it's important to you to finish all your homework, to read all the lectures, because there is only one unit to finish all the course. So please, if we can help you to finish all the materials in the time that we have projected, please let us know how we can help you. So I will wait 1 second because there's people typing questions. So Alistair is asking, why don't you use the inbuilt margin function Stata? To be honest, I'm not related to the inbuilt margin function in Stata. When we did this study for the first time, we test the group of the economists of UNDP. We test a lot of different functions. Probably we test that, and we use the M-change because it seems like is the one that it works better with this type of data and with the Probit. But if you want, I can search a little bit about the inbuilt margin function, and I can write you an email or answer you through the forum about that function, and also for the other students that are interested in knowing that. So I think that there are not more questions. There is a form that you have to fill about your participation, so please help us with that. And thank you very much to all of you to participate of this forum. For this webinar. There is only one webinar next, the last webinar of Unit 4. So we hope that you will also participate. And again, if you have any question or any comment, please use the forum or send us an email. So thank you very much to all.